Alright, hello everyone. So today we're going to be talking about vertical circles, okay? This week, or last week, we did all horizontal circles. Now we're going to talk about vertical circles. So if you imagine a situation like this, right here, we would be at the bottom of a vertical circle. And this is my hand. Let's say, I don't know, I'm holding a yo-yo, okay? So this orange thing is a yo-yo. You're swinging it around like that in a vertical loop. So I want to talk about the forces on this yo-yo. So what force is always acting on everything? It's pulling you towards the center of the earth. That force, of course, is the force gravity. And then there's another force acting on the yo-yo. The force comes from the string right here. What do we call the force in a string or like a rope that's pulling something? That's force tension. So we have force gravity and we have tension. Now, I want you to ask yourselves, when we're in circular motion, which way does acceleration go? Which direction are we always accelerating towards? Well, if you remember, we are always accelerating towards the center of a circle if we are in circular motion. So if my acceleration is towards the center of this circle, how big should my force tension be? If I want the net force to go towards the center of the circle, should tension be smaller than gravity? Should it be the same size as gravity? Or should it be bigger than force gravity? In order to accelerate towards the center of the circle, and at this moment, which that would be up, force tension would have to be bigger than force gravity. It would have to overcome force gravity. It would win that battle and pull it up. So this would be the force tension right there, and I'll just say T for tension. So because we're accelerating towards the center of the circle, the net force has to be towards the center of the circle. So tension must be bigger than gravity here. So remember, the equation we work with all the time for centripetal force is Fc, force centripetal, equals mv squared over r, right? So, what do you guys think the centripetal force would be in this case? Remember, centripetal force can be any combination of forces. Centripetal force is the net force towards the center of the circle. It could be one force, it could be multiple forces. So in order to write the centripetal force, you need to say, well, what is the net force towards the center of the circle? At this moment, the center of the circle, that direction would be up. So what is the net force going up? How would I write that for the centripetal force? Well, if towards the center of the circle is positive, or at this moment, if up is positive, I have a positive force tension. Now, would that be my centripetal force? No, I'm not quite done yet. I have a positive tension towards the center of the circle, but gravity is fighting that. Gravity is saying, I want to pull you down. So I have a minus force gravity right here. So this whole piece, this is my centripetal force in this case. It's actually two forces. The centripetal force is the net force towards the center. So the net force towards the center of this circle at this moment is tension going towards the center minus force gravity going away from the center. So this, both of these together is my centripetal force, and that just equals mv squared over r. Okay? Okay, so we just did the centripetal force for the bottom of a vertical circle. You just saw that. There should have been like an edit cut there. This was the bottom of a circle. But what about if we want to talk about the top of the circle? So it's going to be slightly different. We're going to have to draw our forces again, and that should tell us how to solve it. So let's put our forces in. Which way is force gravity always pointing? It's pointing down, right? We have force gravity pulling this yo-yo towards the center of the earth, pulling it down. Now, there's a difference here, right? Before we had tension at the bottom, pulling it up. Which way is tension going to pull the yo-yo now? Which direction is tension, that rope or that string, which direction is the tension pulling? So tension, the key difference here is that force tension is pulling down now, since we're at the top of the circle. So now, force gravity and force tension at the top, they're actually pulling in the same direction. So of course we can start with force centripetal equals mv squared over r. Now I want to write the centripetal force for the top of the circle. So again, centripetal force is the net force, or the combination of forces towards the center of the circle. So let's look at my free body diagram. I have force gravity pulling down. Is that going to be positive or negative? At this point, is force gravity pulling towards the center of my circle, or is it pulling away from the center of my circle? Well, force gravity is pulling towards the center of the circle, so that's going to be a positive force gravity. And then ask yourself the same thing for the force tension. Is force tension pulling towards the center of the circle, which would be positive? Or should we subtract it? Is it pulling away from the center of the circle? So you can see this string here, it's pulling the yo-yo towards the center of the circle. So this is a positive force tension now. So this chunk here at the top of the circle, this is my centripetal force. And of course, that equals mv squared over r. So this is for the top. So just so you can compare, at the top of the circle, both these forces are pulling towards the center of the circle. So this is my centripetal force. But at the bottom of my circle, only tension was pulling towards the center. Gravity was not. So we had a subtraction sign here. Okay, that's the difference between the top of the circle and the bottom of the circle. All right, so there's one more scenario we can talk about. Not the top, not the bottom, but what if the yo-yo was at the side of the circle, the side of this vertical loop? Okay, what would the forces be? Well, we still have force gravity pulling it straight down. So here's force gravity. And then, of course, the string still has tension. Tension's going to pull it to the center of the circle. There's my force tension. So when I write this equation, right, my force centripetal equals mv squared over r. This is my free body diagram. Not sure if you guys can see that. Let me drag that down. If this is my picture, which of these forces are pulling towards the center of the circle? Am I going to add the forces, subtract them, or what's going to happen? What do you think? Well, let's see. Remember, my centripetal force is only the net force pulling towards the center of the circle. So I have tension pulling towards the center of the circle. Here's T for tension. What about this force gravity at the side of the circle? It's pulling straight down. Is any piece of gravity pulling this yo-yo to the center of the circle? At the side of the circle, no. Gravity's not pulling it to the center at all. Gravity's just pulling it down. It's not pulling it to the center of the circle. So we don't have gravity in this equation at all. The centripetal force for the side of the circle is just tension. So tension is going to equal mv squared over r. And this is for the side of the circle. We have this equation because gravity is not pulling it to the center, and it's not fighting it. It's not pulling it away from the center. It's completely not in the direction of the centripetal force, so we're not even going to worry about it.